550 CE, or even before that, in pre-Roman times in Egypt. They actually took moldy bread, and this is a bakery in Egypt. They took moldy bread and they would put it on wounds to prevent infection, because they noticed that that would lead to a lesser infection. And so researchers today, when the way they discovered this regular use of a compound called tetracycline, which is used in penicillin, it's a very common antibiotic, they found it in the bones and in the mummified corpses of people from Egypt and Sudan. And the way they tested for it is in a means that is very similar to that of carbon dating, which I don't know if you're familiar with, but carbon dating effectively looks at the decomposition of carbon, the carbon isotope, and then it figures out exactly when things are dated. Well, this tetracycline binds to the bones, and the teeth. So what they do is they look at these people and they look for the traces of tetracycline, which is a unique compound. We don't produce it ourselves, mold produces it. And so from there, we determined, wow, they were actually kind of ahead of the game in terms of health and in terms of epidemiology. But that's not where we got antibiotics. We don't rub mold into our wounds and into our infections. So instead we looked to modern scientists. In 1904, a man by the name of Paul Ehrlich wanted to discover a cure for syphilis. Does anyone not know what syphilis does? Or you have a vague idea it's an STD, it makes your skin fall off and it makes you go crazy? Well, it plagued the early 20th century. People had it all the time. And so this man, Paul Ehrlich, that's not Paul Ehrlich, by the way, that's Alexander Fleming, I'll discuss him in a second. But Paul Ehrlich wanted to discover a cure. He called it a magic bullet, and he based the idea off of synthetic dyes and how certain material absorbed certain chemicals and certain colors. And so he figured, why can't disease be the same? Why can't we have treatments that don't affect the host but do kill the parasite? And so he started this series of tests. It was very systematic. He took over 5 years, 605 rabbits, little cute rabbits, infected with syphilis. And then he tried all kinds of compounds, all kinds of antimicrobials. And from there, he was able to discern on the 606th rabbit, 5 years after the fact, that there was one compound that was highly toxic to us, but in low enough dosages killed off the syphilis bacterium. It was called atoxyl, but it wasn't good enough for the mass population. If you're old or if you're young, it would probably still kill you. And so from there, that groundbreaking research and those systematic methods are now what we use for drugs. So his legacy still carries on even if the compound itself isn't in use. So then we go to the more famous one. Everyone knows Alexander Fleming if you took one biology class in high school or some health class. He's the man who discovered penicillin. Essentially what happened was, you see that plate, it's called an agar plate, and basically it's food for bacteria, so you can grow a lot of bacteria on it. And so what he did was he took this very specific strain of bacteria, which you can find on your skin, you can find it in your throat. It's called staphylococcal. It's also akin to food poisoning, and it also can cause the ever fun staph infection where your skin disappears and gets eaten away. Well, anyways, I digress. He had a bunch of staphylococcal colonies on these agar plates, and so what he discovered on September 3rd, 1928, due to some negligence, he got some mold spores that grew on the plate. And so this little colony of mold, about the size of a quarter, grew on that same agar plate, and around it, none of the staphylococcal bacterium were there. It was just empty. And it was fascinating, and he wanted to discover how to isolate the compound that prevented these bacteria. This was the cure. Well, he spent 12 years trying to figure that out and trying to isolate that cure, and then eventually just gave up. He couldn't find it, he couldn't isolate it. And so it wasn't until 1940, actually, where two Oxford students, Howard Florey and Ernest Chain, they actually discovered how to isolate the compound that would become penicillin. But it was during the war, World War II, and so all the chemical factories were working to build bombs and things that killed people instead of things that saved people. So they actually took their work to the United States, which had many more factories to work with, and that was the first production of penicillin. And from there, it spread across the entire world. And so now you can thank all of these men, and even go as far back as the ancient Egyptians to figure out who to thank for our treatment right now in medicine. But what they didn't have that we have today is they didn't know the difference between a virus and a bacteria, and they didn't know how to treat them differently, which is what Shane is going to teach you about right now.